Welcome to our next chapter, Chapter 7. We're going to deal with simplifying rational expressions. Well, let's start with some basic review and definitions. So first off, what is a rational expression? Well, rational or ratio refers to a fraction. An expression is a mathematical thing that can have x's, but it has terms. They're separated with plus and minus, division, etc. So there is no equal sign. We're not solving for anything. And it's going to involve fractions. In fact, we're going to usually deal with the fact that there's a variable in the numerator and or the denominator, often both. So please be aware that how this is going to work. Well, this means we're going to have to talk about fractions. And specifically, how do I simplify a fraction? So if I give you this fraction, 12/5, how would you simplify that? I want you to pause the video and simplify that fraction. All right, so hopefully you've already solved that. You've noticed that if you take the moment, you can factor the numerator and denominator into 3 times 4, that's 12, and 3 times 5, that's 15. Well, what do they have in common? They both have 3, so those 3's cancel out. Since the 3's cancel out, all that's left is 4/5. All right, so we're going to use that same idea, but now we're going to deal with a rational expression. So let's look at what a rational expression looks like. Here's one. I have 7x plus 28 on the top and 21x on the bottom. Now notice the first step we took in simplifying a fraction was that we factored it out. So can you factor that numerator? Hopefully, if you take a moment to do it, you recognize it has the greatest common factor of 7 and left with x plus 4. I can also factor the 21 into 7 times 3x. Well, since they both have a 7, the 7's will cancel. And we're left with x plus 3/4 over 3x. For some reason, that multiplication symbol showed up. But these x's are not going to cancel out. This x on top is attached to the 4 by addition, so it will not cancel out. So if you cannot factor them and that numerator is prime, the denominator is prime too, since I cannot factor them and they have no common factors, we're done. Let's do another example. This one is a bigger polynomials. Can you factor the numerator and the denominator? So go ahead and pause the video and factor it. Welcome back. Hopefully you already factored this and you recognize the top is a difference of squares. So you end up with x minus 1 and x plus 1, and the bottom turns out to be a perfect square. Or you can just use the rules of trinomial factoring and get x plus 1 times x plus 1. What do they have in common? Well, they both have an x plus 1, so those are going to cancel out the x plus 1 on the top, and only one of the ones in the bottom is going to cancel, because it only cancels 1 for 1. What's left over? Well, x minus 1 over x plus 1. And again, those x's will not cancel because they are actually attached by addition or subtraction. So it's only things that are attached by multiplication to the rest of the numerator can I cancel out. So be careful about that. Let's do another example. X plus 1 over x squared minus 2x minus 3. Go ahead and factor the numerator and denominator and see if there's anything that can cancel. Go ahead. Hopefully, you recognize that the numerator is prime, so I can't factor it. But the bottom can be factored into x plus 1 times x minus 3. Well, they both have an x plus 1, which will cancel out. That doesn't mean the numerator goes away. There's actually a times 1 that's hidden in the top that we're just not paying attention to. So we end up with 1 divided by x minus 3. So 1 over x minus 3 is a simplified version of that original expression. So this is how we can get it. So I want you to notice how much is this dependent on your ability to do factoring. So if you struggle with factoring, go back to chapter 6. It's really, really important in this chapter that you can factor well. Let's do another example. X minus 7 divided by 7 minus x. Go ahead and pause the video and see if there's anything you can factor out. Well, this one's a little bit curious, and that's different. It would look like you can't factor anything out, but you actually can. I can factor a -1 out of the denominator. I can always factor out a -1. Why, you might ask? Well, I just like to have a positive x. I'm a positive individual. But if I rearrange that, notice if -7 plus x, the same thing as x minus 7. Oh, wait a second. Now, those will cancel out, and I'm left with 1 over -1, or in other words, just -1, because 1 divided by -1 is -1. This particular situation where you have a difference, there are two subtractions that are in the opposite order of each other, will always come out to be -1. So you need to look and see, are they similar? If they're just subtraction in different order, then it's going to be equal to -1. And you can play with that a bunch of numbers. I mean, 3 minus 2 is the negative version of 2 minus 3, and vice versa. All right, so let's do another example kind of employing this. I want you to try to simplify this. So go ahead and factor it and see if there's anything that cancels. Welcome back. Again, our numerator is a difference of squares. And the bottom, notice again I could pull a -1 out. I just generally like to do this because I like to have positive x again, because that's how most of my things are. But it also allows me now to have x minus 1 and x minus 1. So those cancel, and I'm left with x plus 1 over minus 1, or in other words, I can multiply the whole top by -1 and get minus x minus 1. I hope that makes a little bit of sense, because you will have some of these in your homework. So be aware that this is one that students tend to trip a little bit on, because it's a little bit unfamiliar, because we often forget about 1 and -1 as being things I can factor out. We can always factor 1 and -1 out. All right, let's still go on. I want to try some more examples. Can you factor these? So factor the numerator and the denominator and see what things cancel. Go ahead. Welcome back. Hopefully, as you work through this, you realize that was x plus 4 times x minus 2 over x minus 2 times x plus 4. Well, what do they have in common? X plus 4. So those cancel, and you're left with just x minus 2 divided by x minus 6. So again, factoring, huge role in everything we're going to do. Let's do another one. Can you factor the numerator and the denominator? Go ahead. Well, hopefully as you approach this, you recognize that first and foremost, can I factor out a greatest common factor? And both of them actually do have greatest common factors. The numerator, I can pull out an x, and I can pull an x squared out of the denominator. That changes what I look like. Now the numerator is a trinomial, the denominator is a difference of squares. If you didn't do that first, pause the video and go ahead and continue from here. Otherwise, keep following. So our numerator, it can factor into 2x minus 5 and x plus 3. Again, I'm skipping all the steps. I'd recommend doing this off to the side. Keep working on your factoring skills. And the bottom, since it's difference of squares, is 2x minus 5 and 2x plus 5. Well, those things are clearly going to cancel. But what about the x's? What it's going to cancel here? Well, x squared is x times x, so only one of those x's will cancel. And x minus 5 and x minus 5 will cancel. Well, if you look at that, the numerator that's all that's left is x plus 3. My bottom has x times 2x plus 5, like so. Now, please notice, you do not need to multiply this back out to enter the answer. You can leave it just like that in factored form. That's actually probably preferential. So just leave it in that form and keep working with it. Here is our last example. I want you to try this one. Can you factor that numerator and that denominator? Go ahead. Welcome back. Hopefully you were able to do that. You notice the numerator is a trinomial, so I can use my standard trinomial methods, but my denominator has 4 terms. 4 terms means factor by grouping. So if you go through that process, you end up with this: 2x minus 3 and 5x plus 1 over 4x squared minus 9 and 5x minus 1. Well, notice this is a difference of squares. I can factor it more. So if I factor it, I suddenly have 3 things being multiplied in the denominator. Now, which of these are going to cancel out? Well, only the 2x minus 3 they have in common, but these, notice, will not cancel out. 5x plus 1 and 5x minus 1. If it was 1 minus 5x, then we can talk about that strategy we did earlier where we factored out negative 1. But 5x plus 1 and 5x minus 1 have nothing in common. So can't do anything from there. So my final answer is simply 5x plus 1 over 2x plus 3 times 5x minus 1. So again, factoring is critical in all of this. Please make sure you're taking the time to go back over all your problems and back over all your factoring. That's going to really help you out as you go further on. Please let me know what questions you have, and good luck with your homework.